Hello, everyone, and welcome to the second part of metric conversion. So, last time we actually discussed converting metric units, which in which the given metric units, no, not metric units, in which the given metric prefixes are from kilo and from kilo to milli or milli to kilo. And we also learn how to convert any unit as long as it's within this range you know, to another unit. Like for example, we learn, let's just say I have 1 meter. So how would I convert it to, let's just say, for example, millimeter? We learn about this. I mean, wait. There you go. We learn about this. So the technique is simple. First things foremost is that you need to know where is meter. That is your given unit. All right. And second, you need to know where is millimeter located. If you're asking me, what do you mean by location? I meant here in this table here. Okay? You must find first where is meter and milli. Now, after that, uh, in this case, since meter is just a common base, or sorry, it's a base unit, so it's here, and millimeter is here. So since we have this, it implies that millimeter is below meter. So that means for you to convert meter to millimeter, here's what you're going to do. All right. From here, you go down per row. But per row, you will have times 10. All right. So from here to this row, it's deci, so times 10. But we will continue until we reach milli. So next we go to centi. So we have additional 10, or I mean another times 10. Then lastly, we stop until milli. So here we have another times 10. So multiply them all together. You have 1 meter is equivalent to 1,000 millimeters. All right? That's the same. That's also similar when you're going to go up. Like for example, if I have let's just say, what's that again? 1 hectometer going to, let's just say, kilometer, right? Kilometer. So you need to locate where's hectometer. That's your given unit, which is here. And kilometer, where is kilometer located? It's here. So that means kilometer is above hecto. So you need to go up. But when you go up per row, it's not times 10 anymore, but divided by 10. So you go up, you will have divided by 10 instead of times 10. So here we will stop right here in kilo, all right? Because that is what we're looking for. So that means 1 hectometer is equivalent to 1 all over 10 kilometers. That's it. All right. Now, we're not going to dig deeper on these type of problems because I already discussed that on the first part. And I suggest that you should watch that part first, the first part of metric conversion, before you proceed here on the second part, because I'm going to discuss another conversion of metric units. I mean, yeah, metric unit conversion based from its metric prefixes. All right. So, kilo to milli, as long as that you're either going up, which is you have to divide by 10, or going down, which is times 10, basically per row is always 10, okay? 10 per row. So when you go down, when you go down, it's times 10. When you go up, it's divided by 10, all right? Wait, let me rewrite this one. All right, it's divided by 10. Now, how about beyond kilo and beyond milli? Okay, like what if we're talking about this way? So in this way, it's just almost the same, right? It's just almost the same, all right? When you go up, you will divide. When you go down, you will multiply, all right? But what's the difference? Here, on the six basic metric prefixes from milli to kilo, when you go up or go down, it's 10 per row, right? Here, this one, like, beyond the six basic metric prefixes, in here, per row is 10 cube, right? Let me write that. It's 10 cube. Okay, 10 cube per row. Okay, basically, when you go up, it's divided by 10 cube or 1,000. When you go down, so that means you have times 10 cube or divided by, or times 1,000. All right. For example, let's just say you have a given unit. Let's just say we have, what do you call this one? Let's just say we have 3 kilometer. All right. No, no, no. Let me just change the color. There you go. 3 kilometers to, let's just say, gigameter, right? Gigameter, all right? So you have to take a look, where is kilo? So based from the table, kilo is just basically, where should I, it's basically here, right? It's here. It's here. Then, since we're looking for giga, so giga is just above kilo, right? 2 rows above kilo. So that means when you go up, you will divide, right? Now, kilo, once you go up, it's mega. So you go beyond kilo. And remember, if it's beyond kilo, it's no longer 10 per row, but 10 cube per row. And since you're going up and you reach mega, so that means you will have divided by 10 cube. Okay? Then you go up again because we're looking for giga, not mega. So here, you have additional divided by 10 cube. And that's it. So what does it imply? So by equivalence, 1 kilometer is equivalent to 10 cube times 10 cube is basically 10 raised to 6. Okay? But since it's divided by 10 cubes, okay, so that means we have 1 all over 10 raised to 6 gigameter. So 1 kilometer is equivalent to 1 all over 10 raised to 6 gigameter. Or, this is just basically the same as 1 all over 1 million gigameter. Okay? Or we can say this as 0.0000001 gigameter. All right? So let's just say we start at this example, like how much gigameters in 3 kilometers. All right, how much? So with that, let's solve this problem. Okay, let me just erase this one. Don't forget this one, right? By the way. Okay, so let me just put it here. Where should I? What's the best way? Let me just zoom out a bit. Right, there you go. And let me just shorten the yeah, the writing. Okay, so we have this one. So what are we going to do? So we will apply dimensional analysis, all right, if you remember. So because we have 1 kilometer is equivalent to 0.0000001 gigameter, so that means you have two fractions. It's either 1 kilometer all over 0.0000001 gigameter, or you have 0. Wait, is it visible? Ah, yeah, it's still visible. So 0.0000001 gigameter all over 1 kilometer. Okay, so you have to select which one of the fraction here that you will use so that if you're going to multiply to 3 kilometers, the kilometers will be cancelled. So the answer is what? Wait, sorry. The answer is the second the second fraction. Because if you use the second fraction to multiply 3 kilometers, the kilometers will be cancelled. So 3 kilometers times 0.0000001 gigameter all over 1 kilometer. So kilometers are now cancelled. So what's left is you will have 3 times 0.0000001 gigameter. So 3 times 0.00001 gigameter, I think the answer would be 0.00003 gigameter. So that means 3 kilometers is equivalent to 0.00003 gigameters. All right, that's it. That is the answer for this problem. All right, let's try another problem. Okay, since we already been here, like kilo to giga, which is beyond kilo. So let's try another problem. All right, let me just erase this. So let's just say I have 30 centimeters going to nanometer. So you must locate where is centimeters, where is nanometer. So, oh wait, hold on. Let me just charge my laptop. Hold on for a while. Okay, so you must locate where centimeter and nanometer are. So centimeter is here, right? It's here. Nanometer is here, right? It's here. All right. So remember, okay, once you go beyond milli, that means that you will not do 10 per row, but it's 10 cube per row or 1000 per row. Remember that, okay? Let me put a boundary here. Okay, let me put a boundary here. Right? So we go centi. Now we will go until nano. So centi, you go to milli. So if it's within these six basic metric prefixes, so it's still times 10. Okay? Because it's going to milli. Now, after we go to milli, we go to micro, which is beyond milli. So if it's beyond milli, it's what? 10 cube. And since we're going down, so we will have 10 cube. All right, times 10 cube. Then lastly, we go to nano. So we have another times 10 cube. Okay, so now we can say that in 1 centimeter, it is equivalent to 10 times 10 cube times 10 cube. That would be 10 raised to 7. Oh wait, no. 10 raised to 7 nanometer. Or this is just another way of saying 10 million nanometers. Okay, it's 10 million nanometers. Now, the problem here is that the number is large, right? So it's up to you if you want to use this in exponential form or yeah, exponential expression. I think that's a better way to say it, or the whole number itself. I think it's better to use this, this one. I think this is much better. But for the sake of this video, since because it's just nano, but if we go beyond nano, that would be a different scenario. So for now, let's just use this, okay? For now. But again, it's up to you, all right? It's up to you. Okay, if you use 10 raised to 7 or the whole number itself. Okay, so we will do dimensional analysis. Okay? So with that, you have two fractions. It's either 1 centimeter all over 10 million nanometers. Or you have 10 million nanometers all over 1 centimeter. Now, which of the fraction here that you will use to multiply 30 centimeter where the centimeters will be cancelled? Again, which of the fraction here that you're going to use where if you're going to multiply to 30 centimeters, the centimeter unit will be cancelled out. So it's the second fraction. All right? It's the second fraction. Okay, so let me erase this one. So we will have 30 centimeters times 10 million nanometer all over 1 centimeter. So here we have centimeters on the left part, which is above, and centimeters below on the fraction, so we can cancel them out. So what's left is we have 30 times 10 million nanometer, right? Nanometers, sorry. So multiply 30 to this huge number, the answer for that would be 300 million nanometers. That is your answer. All right, 30 centimeter is 300 million nanometers. All right, let's try some few more examples. Let's just say two more. All right, let me just erase this. Okay, let's just say you are within the range that is not on the six basic metric prefixes. Like, for instance, let's just say you are in Tera. Okay, let's just say you're in Tera. Here in this unit. Okay, suppose I have 5 tera, let's just say grams, teragrams. All right, gram is a metric unit. All right, so we can use this 5 teragrams. Now I wish to convert it into, let's just say, hmm, let's just say to mega, right? Mega. Okay, so let's try tera to megagrams. Okay, let's do that. So where is tera? Just right here. Where's mega? Just right here. Okay? So 2 rows below tera. So that means you will go down. And again, when you go down, it's what? Per row, it's 10 cube. Okay? And again, when you go down, it's times, not divide. Okay? So tera to giga. So you have 10 times cube. And giga to mega, we have 10 times 10 cube. All right, and that's it. Okay, we're going to stop right here. So that means in 1 teragram, this is equivalent to 10 cube times 10 cube, which is 10 raised to 6, or 1 million megagram. Okay, now we do dimensional analysis. Okay, first you have two fractions given, 1 teragram all over 1 million megagram, and we have 1 million megagram all over 1 teragram. All right. So, the same question, which of the fractions here I will use to multiply 5 teragram, in which the teragram will be cancelled out? Again, which of the fraction here I will use so that when wait, which of the fractions I will use to multiply to 5 teragram so that the teragram unit will be cancelled out. So it's the second fraction, or on the right. Okay. So we have, let me just erase this. All right, let me erase this one. So yeah, we have 5 teragram. All right, times 1 million megagram all over 1 teragram. So the teragrams are now cancelled. Okay, so what's left is you have 5 times 1 million megagram. So 5 times 1 million megagram is 5 million megagram. Okay, that's it. That is your final answer. Okay, we're good to go. Now let's have one last problem. Let's just say it's a bit complicated. Let's try to have some challenge. Okay. So let's just say that this is actually very big, by the way. The problem I'm going to discuss here. Let's just say that um let's just say you have micro. Okay, micro, or you know what? Let's just do nano. Micro or nano? Nah, let's do uh you know what? Yeah, let's just do nano. All right, nano. So let's just say I have 10 nanoseconds and I wish to convert it into gigaseconds. Oh my God. Okay. So let's locate where's nano. Nano is here and giga is here, right? Let me erase the other dots. Right? Giga is here. So that means I have to go up. And by going up is I have to divide, all right? Not times. So we have to go per row as usual. So nano to micro. So it's since it's micro is beyond milli, so that means we will use 10 cube, not 10. Okay, so divided by 10 cube. Then after micro, you go to milli. So here in milli, you are within the six basic metric prefixes, so you will use 10, not 10 cube. Remember that. Divided by 10. Then going to centi, okay, the same thing, divided by 10. Going to deci, divided by 10. Going to the base unit, it's still divided by 10. Going to deca, it's still divided by 10. Deca to hecto, divided by 10. Hecto to kilo, divided by 10. All right. Now we go beyond kilo, in which the next row would be mega. So if it's beyond kilo or beyond milli, it's 10 cube. Okay. So you will have divided by 10 cube. And here we go mega to giga. So we have 10 cube. All right. So there are actually a lot of the tens here given. Okay. So let's have the equivalent. So that means in 1 nanosecond, this is equivalent to uh 10 cubed times 10, that would be 10 raised to 4, times 10, 10 raised to 5, times 10, 10 raised to 6, times 10 raised to 7, times 10 raised to 8, times 10 raised to 9, times 10 raised to 10, times 10 cubed raised to 13, times 10 cubed raised to 16. So that means you have 1 all over 10 raised to 16 gigaseconds. Okay? Or it's better if you would, what do you call this one? If you would rewrite it this way. All right? I'm not gonna write the whole number because if the exponent is greater than 8 or maybe 9, of course it will be a huge number. So let's just keep it that way. All right? But what I'm trying to say is we can make this 10 raised to 16 go up here. But if you're going to put it up, the sign of the exponent will change. So from 1016, it would become 10 raised to negative 16. Okay? Gigaseconds. So 1 nanosecond is equivalent to 10 raised to negative 16 gigaseconds. And we will do dimensional analysis as usual. So you have two fractions. It's either 1 nanosecond all over 10 raised to negative 16 gigasecond, or we have 10 raised to negative 16 gigasecond all over 1 nanosecond. So here's the question. Which one of the fraction that you will use for you to multiply 10 nanosecond, in which the nanosecond will be cancelled out? So it's the second one. All right. So let's erase this, and we will multiply 10 nanoseconds by this fraction. So here we can now cancel the nanoseconds. And what's left is we have 10 times 10 raised to negative 16 gigasecond. So here we can leave this as our final answer. We can do that. Okay? Or or you can simplify this actually. 10 times 10 raised to negative 16, if you're going to simplify it, this is actually 1 times 10 raised to negative 15 gigasecond. All right? If you're asking me why, well, here's the thing, right? 10 times 10 raised to negative 16, all right? We have the same base here, right? The same base. So uh what happens if the base are the same? So remember, according to the one of the laws of exponent, if you have x raised to n times wait, no, 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 x raised to n times x raised to m, the same base, and they have their own exponent, you can just simply copy the base and add their exponents. So here on the 10, since it's just 10, that means it has an exponent of 1. So therefore, you have 10 1 times 10 raised to negative 16. So you will have what? 10 raised to negative 15 gigaseconds. All right? So your answer could be what? 10 raised to negative gigaseconds. You can leave it this way. Or you can leave it as 1 times 10 raised to negative 15 gigaseconds. Now, here's the question. Is this valid as our answer, like 1 times 10 raised to negative 15? Yes, it's valid. Now, the question is why? Well, first things first, according to the identity property of equality, wait, what's the, wait, no, no, no. Well, first things first, basically, according to identity property of equality of a given equation, for example, A is just the same as 1 times A or 1 times A, you know. So we can just rewrite 10 raised to negative 15 to 1 times 10 raised to negative 15. So that's valid. Okay? That's the first reason. Second reason is related to the next topic that we're going to discuss, which is scientific notation. All right? So yeah, this is the second part of metric conversion, and I hope next video we're going to talk about metric and English conversion, which is this one. All right? So we're going to talk about this next time. See you soon.